Hi, this is Steve Brightfield, Chief Marketing Officer at BrainChip, coming to you from the Consumer Electronics Show in Las Vegas. We are here talking to key partners, industry analysts, and leading developers of electronic products in the market to get a feel for what is in the future for AI, particularly AI at the edge. I'm joined today with Jeff Bier, founder of the Edge AI and Vision Alliance, an industry-leading organization of probably over 100 companies. Is that right, Jeff?
Yep.
That has been at the edge of Edge AI for probably a decade here. He is considered one of the industry's most knowledgeable and experienced luminaries in this field, and we're very much pleasure to have you with us, Jeff. Thank you so much.
Well, thanks for having me, Steve. It's great to be here.
Well, Jeff, you and I have known each other for quite a long time. I remember when you first started the Edge AI Alliance, and you've really kind of transformed that into an industry-leading organization that has really cross-fertilized the industry with a lot of people in not just the developers of the technology, but the consumers of the technology, and trying to understand how this adoption cycle works, both for people developing end products and those trying to service those with either software, chips, or IP. So I'm really pleased to hear kind of your viewpoints in 2025, how this market has transmitted into a large industry. When you started this, it was really you could fit everybody into a small room that was doing this kind of work, right?
Yeah, we started in 2011 or so, going on 15 years. And at that time, the notion of doing edge AI and computer vision in kind of everyday products and doing them at the edge wasn't really a thing. But it's been really exciting to see this develop and gain momentum. And I think it's gaining momentum faster and faster each year. Walking around the show floor here at CES, it almost seems like there are more end products, whether it's a car or a piece of consumer electronics or some kind of industrial safety equipment, that have AI or some other form, computer vision or some other form of AI in them than don't. It's becoming a sort of ubiquitous capability. And it's kind of like the way, you and I previously worked in wireless communication, right? So 30 years ago, if I'd said, well, you're building, I don't know, let's say a beverage vending machine, what kind of wireless communication are you going to put in? You would have given me like a very puzzled look, like, why would I put wireless communication in a vending machine? These days, it's exactly the opposite. If you're building a vending machine, it doesn't have wireless communications. You've obviously overlooked something very important. How are you going to update the firmware? How are you going to update the prices? How are you going to find out when it needs to be restocked? Of course, it's going to have wireless communication. Well, we're getting pretty rapidly to that point with this kind of sensor-based AI that enables machines to understand what's going on around them, where instead of asking the question, why would you do that? The question is becoming, well, why? Of course you're going to do that. It's becoming now a question of, well, how are you going to do it? What are the key capabilities you're enabling? And how are you going to do that in an efficient way in terms of the hardware cost and oftentimes the power consumption, so that it's a economically viable thing.
Well, that's really insightful because, when I attended the CES keynote, we heard from Jensen Huang of NVIDIA, and it was data center, data center, data center, and the explosion in the market and the data center. And the whole conversation about Edge AI has been kind of on the edge of conversations. It hasn't been a central theme of this event or many other events. That's why I really appreciate you set up a forum and an event itself in May that really is focused on Edge AI. Tell us a little bit about the event that you guys hold.
Yeah, the event's the Embedded Vision Summit, and it takes place in May. It's the week of May 19th in Santa Clara in Silicon Valley. And this is really an event, and I think the only event designed for people who are building all kinds of systems and solutions and applications incorporating computer vision and other forms of sensor-based AI. There are a lot of academic research conferences out there on computer vision and AI, but they're not really focused on what's practical and how do you build a product. And then there are a lot of I call them cheerleading hype conferences with, strobe lights and laser light shows and smoke effects, designed to wow people about the
Like CES. Yeah.
exactly. um, Designed to wow people about the potential. But in between kind of those two ends of the spectrum, there's a real need for people who are building all kinds of products, from kitchen appliances to mining machines to medical diagnostic systems to retail analytic systems. People who are building products who need to understand, well, how can I build a better product, deliver more value to my customer using these kinds of capabilities? And that's what the Embedded Vision Summit is focused on. It's focused on the needs of those system developers, helping them realistically assess, what is this technology capable of? How does it work? What are my options for different kinds of models, software tools, processors, development techniques? What are the trade-offs? What are the pitfalls? And how do I overcome those pitfalls? So that's the Embedded Vision Summit in a nutshell, the week of May 19th in Santa Clara.
Great. And just for a disclosure, BrainChip is a member of Jeff's organization, Edge AI and Vision Alliance, and we will be there. And hopefully, you'll accept our abstract for a presentation so that we can further understanding BrainChip's technologies. Now, at CES here today, we launched, we had two press announcements. One was the launch of an M.2 core card that incorporates our AKD 1000 chip on it that can go into highly embedded systems. And earlier last year, we announced an Edge AI box that incorporates two of those devices into a compact standalone computer that you can put on the edge. But that confuses people because they think, oh, we're in the end product or we're in the chip business. We're really in the IP licensing business. And the reason that we really did the boxes and the chips as a developer platform for people to put that down on a desktop, program it, demonstrate it, and do proof of concept so that they reduce the risk and they get the validation of the use case before they commit it to an expensive SoC integration. To that end, I really like to get your kind of viewpoint on what challenges do developers have really taking an algorithm or use case and integrating it into a product on the edge, an edge AI and focused product.
Yeah, well, there are lots of challenges, but I'll focus maybe on two or three based on the results of a survey that we recently completed, where we surveyed about 300 system developers building different kinds of end products for different industries, incorporating computer vision and other forms of sensor-based AI. And one of the things we asked them about is, what's difficult about your product development process? What's holding you back? And some things that really stand out. One is training data. Training data to train models is almost universally a problem. Getting the training data, cleaning it, curating it, making sure it's a balanced data set, then maintaining it over time as the environment, the application changes, just very burdensome for most developers. And therefore, emerging techniques which enable few shot or zero shot learning, for example, where you have a much reduced need for training data, I think are very exciting and interesting.
I think, BrainChip recognized exactly what you're saying. And that's why, as part of their Edge AI box, we partnered with Edge Impulse, which provides a SaaS platform for you to import data, do labeling, do that training, and tune that model. And then you can deploy that directly down to the box to do some real-time evaluation and understanding how well that training did, and then you can go iteratively that. And once you even deploy a product after it's integrated in SoC, you'll continually be updating that model as the requirements change or the data sets change. Say you go into a new country or there's new products that you have to identify that always requires that training. I want to do a plug for neuromorphic computing, which is that we can do edge training. We can actually do this one-shot training on the device, which is kind of unique for a lot of AI edge providers there. But on the other side of the coin is neuromorphic has even more challenges than, say, conventional edge AI, because it looks at it implements the algorithm a little bit differently than most people are used to when they get their initial training in edge AI. Can you comment a little bit on that?
Yeah, I would say, the next challenge that I was going to mention that emerges from our recent developer survey is, people have difficulty figuring out, well, what's the right model that I should be using, and then getting that model mapped in an efficient way to their target processor so that they meet their power, performance, and cost constraints. One of the real benefits of neuromorphic computing is, for the right types of applications, it can yield really good efficiency. So can potentially significantly reduce cost and power consumption, but you've got to have the right model that meshes with that processor. And so, that's, I think, an example of this challenge. Well, okay, I'm interested in using a neuromorphic processor to get the advantage of the lower power consumption, lower cost. Now I've got to find the right model. I've got to choose the right model and make sure that that model will meet my requirements in terms of accuracy for the application, and figure out how to get that model implemented in an efficient manner on the target processor. And that's a sticking point for a lot of developers. First, selecting the model, getting the right model, also getting the right processor, and then getting that model running efficiently on the processor. You'd like to think it would be a really straightforward process, but it isn't. So I think, neuromorphic processors are very interesting, and offer, some very exciting potential. And they're also an example of this challenge where, okay, to get the full advantage of the neuromorphic processor, I've got to select an appropriate model, and I've got to have the right process for mapping that model onto the processor.
Excellent. So I think you touched on a theme there that I wanted to explore a little bit more. And it's not just about the edge AI computing or the neural processing unit that actually does the calculations. It's the model itself. And we've seen the AI market rapidly innovating with lots of new models. And it's really hard for a developer to select which model he's going to utilize. And is he going to be married to that model, or is he going to be changing that to a different architecture? And if he does change that to a different architecture, how will that run on his edge AI device itself? I know when this market started, it was all about convolutional neural networks, or CNNs. But then we've seen the edge AI market work to compress and optimize CNNs to work in devices. But then transformers happen, right? And transformers have a whole different computational profile. And maybe you could comment on how you see transformers, what the challenges you've seen on getting them to the edge.
Yeah, well, transformers have been, a huge development, of course, enabling these large language models like ChatGPT, but then perhaps not as widely known, they also bring very powerful capabilities for computer vision, for example, and other kinds of, perception, including multimodal perception, combining maybe audio with camera images, for example. But as you said, they fundamentally have a different type of computation at their core, and also different type of memory access, and they're even more intensive on memory access than the previous generation, CNNs. So if a compute engine was designed and optimized for CNNs, it's not necessarily going to run transformers efficiently. Right. So when somebody's transitioning from CNN to transformer, they have to really look at, well, do I also need a new processor so that I can now run transformers efficiently? And again, not only about the processor, do I have the right memory system so that I have the capacity to run the transformer and enough memory bandwidth to keep the processor fed?
Well, you hit on the two of the key points that that BrainChip has been working on in 2024 that we're out in 2025, and one is incorporating visual transformer-based capabilities into our Akita 2 platform, which is out now, and we have an FPGA platform that we're actually allowing developers to run those models so that they can evaluate them in an SoC. And we actually look beyond transformers because we see that there is a computational bottleneck there at the edge to use a new class of models that are called state-space models. And BrainChip likes to think that it's a very fabric company because we developed some of the very first state-space models, probably about the same time as Carnegie Mellon University and Stanford, but they tend to get all the fame because they publish an open source model. Mamba is the model that's out there. What we've seen is that paper that came out in 2021 has now got over 1,000 papers and citations, and there's a lot of innovation and development on that. So we look to be able to support both CNNs, transformers, and state-space models with our new architectures. And how do you think that is going to affect the edge AI market, this constantly changing landscape of models?
Yeah, well, I mean, it's a double-edged sword. On the one hand, it's very exciting and promising because each new generation of models brings new capabilities, whether that's improved accuracy, added functionality like multimodal perception, or more efficient ways of achieving functionality that we previously implemented other ways, but it's hard to keep up. It's hard for, product developers who aren't researchers just focused on the models to track, okay, last year I was using CNNs, this year I'm using transformers, next year I'm going to be using state space models. And it's hard for the suppliers of the processors and the software tools also to keep up so that they are supporting these new classes of models that are emerging every year in a way that makes it easy for the system developers to implement them on their processors.
Well, great. Thanks for that perspective. I really appreciate it. It helps kind of validates what BrainChip is doing. We see the opportunities to state-space models to reduce the memory model sizes. I know that's the big thing in LLMs, trying to get the model size down. We took a completely different approach rather than taking transformer foundational models and trying to shrink them, or they say distilling them, but it's really throwing away information, to using, training our own state-space models, and that demonstration we have of Edge LLM working in an environment, we get the model size a third of a transformer size model. But the key, what we've been able to do is demonstrate dramatically lower memory bandwidth and compute power, which makes it more suitable for an edge AI device. So we're hopeful that the industry recognizes that. Now, one of the things that we've tried to do is impact the educational. So we have a university program, CMU is part of that program, Penn State. We've got a lot of wonderful universities there. Tell me about how Edge AI Alliance does education for this market as well.
Yeah, so I would say that education for product developers about practical aspects of AI and computer vision and how to implement them in products is really our number one focus. And we do it through a variety of programs. I already mentioned the Embedded Vision Summit. That's our conference coming up in May in Silicon Valley. But in addition to that, we run webinars. We have a website with just a vast library of high quality, free, technical educational content, especially presentations from real world-class experts. These aren't researchers who are presenting, bleeding edge of new techniques that were just discovered. These are practitioners, product developers who are showing how they've actually used these different classes of models, tools, processors, and so on to build real-world products, and what's gone well and what hasn't gone well, how they've overcome the challenges, what trade-offs they've considered, what decisions they made, what they're going to do differently next time. And I think that's really valuable resource for, product developers. This is a new space and a very rapidly changing space. And, it's good to learn by doing, but it's also good if you can learn from what other people have done who may be, 6 months, a year, 18 months ahead of you. And that's a lot of what we try and deliver through the Embedded Vision Summit conference, through our webinars, content on our website, and so on.
I have to admit to you, every time I attend one of your events, I learn something new, and the speakers you have are fantastic. They're typically, like you said, have a sound academic background, but then have applied that and
Right.
in a leading way. And then they come into these events and they tell us how they went through that journey and really what that process was, that developer journey that we're always trying to crack here. So I'm sure all our listeners are kind of probably fascinated with this. And how do I get kind of more information about that?
Yeah, best way to do it is to visit our website, which is edge-ai-vision.com. Again, edge-ai-vision.com. You can access hundreds of really high quality presentations there, articles, access about information about the Embedded Vision Summit conference, and lots of other resources, including if you're looking for a technology supplier, for example, a processor supplier. We've got a great resource there we call the industry map to help you find, well, who's working in this space that I might want to talk to.
Yes, I've met a lot of companies that have either been partners for us or customers or vendors for us in your forum. So it's been a very valuable resource for us as a company. So your focus on edge AI is so crisp, just like BrainChips. Since we're at CES here, people go, what is you see out there on the show floor that has edge AI in it as an interesting product that you haven't seen before and that you think is going to turn into a trend in the industry?
Yeah, well, I think we're just starting to see the very earliest cases of people implementing uh, combined large language models and vision models in various ways to create systems that can understand both language and vision, which is very powerful. So, for example, being able to create an industrial safety monitoring system that uses cameras and is able to interpret safety policies that are written down in text in a manual, and then look at what's happening in a scene and correctly interpret whether the policy is being followed or not, and then know what the appropriate remedy is if the policy is not being followed. I think the combination of language plus vision, as well as potentially other kinds of sensor data, is even more powerfully nice. Sometimes you hear the sum is greater, than the whole is greater than the sum of the parts. This is definitely a case of that where, yeah, it's great to be able to understand language like an LLM. It's great to have computer vision where machines can interpret images. But if you bring the two together, you actually get more. It's a 1 + 1 = 3 or maybe 10 kind of situation where entirely new things become possible that even a year or two ago I wouldn't have thought would be possible. For example, like in a video security application, sure, today we can assess, like, is there a person present? But more subtle things like, is there a person present behaving in a suspicious manner? Do they look like they're trying to hide something? Are they trying to conceal their face? That's something we can't really do with the current mainstream computer vision techniques, but with this new class of language plus vision, we can. And so this is opening up really vast new capabilities, and we're just starting to see the first products that incorporate this combination of language and vision understanding.
Well, I can see two paths that will take. One is the Big Brother path, where there's a data center in the cloud model that's doing multimodal, and that's going to really start controlling the actions of people. But then the other path is if we can implement that on the edge, then it becomes an assistant to that individual to do his task better and guide him, and that allows maybe that individual to customize that model running on the edge so that it's going to be basically learn his habits and maybe reinforce positive habits for him without it being a surveillance state that's doing this for him. What do you think about that?
Yeah, I mean, edge is required for so many reasons. One is privacy, for sure. There are a number of companies, for example, that make vision-based systems to help with the safety of elderly people, whether at home or in hospitals or elder care facilities where, someone falling is a huge risk, and falling and then not detecting that they have fallen for maybe hours, if it's at night, can mean the difference between life and death. So you want a camera in the bedroom. You really even want a camera in the bathroom where falls are common, but you really don't want the images leaving the camera.
Right.
So you really, really want the processing to happen at the edge for privacy and also for cost, because if you're streaming thousands, hundreds of thousands of camera streams to the cloud, that gets very expensive very, very quickly.
So really what you're saying is even if these technologies are being developed in the cloud, the market drive for privacy and security is going to push these algorithms to edge anyway, because consumers and even corporations don't want the information in their personal life or in their enterprise environment, being shared with the cloud.
In many cases, yeah. Or even if it's not a privacy concern, from the point of view of cost and reliability, that may drive the decision to do the processing at the edge.
Great. I know you have to run off. You've got a busy schedule here, but maybe you give us a last thought of where you think the edge AI industry is going in the next 5 years.
Yeah, I think, I talked earlier about digital wireless communication. 30 years ago, it was this niche, very expensive, exotic, complex technology, and who had digital wireless communications like broadcasters and government agencies and so on. And now, literally, as I'm sitting here, my wristwatch has digital wireless communication. My car has digital wireless communication. My thermostat has everything has digital wireless communication because having things connected delivers tremendous value. We're on a similar trajectory with Edge AI, where right now already your phone, right, has sophisticated AI to do things like noise cancellation and allow you to remove objects from the background of unwanted objects from the background of a photo and things like that. It's it's moving out from phones to just about everything. Your robotic vacuum cleaner, your thermostat,
Right.
your kitchen appliances, your PC. All of these things are going to be enabled with really valuable capabilities, whether that's noise cancellation, better speech recognition, more better safety features for your cars, enabled by accurate and efficient, from a cost and power point of view, efficient edge AI. So I think we're at the very beginning of this massive wave. Just like over a period of 10 or 20 years, just about every device gained wireless communications capability. Over the next 10 or 20 years, just about every device is going to gain some kind of AI capability that's going to improve its capabilities, its autonomy, its ease of use, safety, or some other factor that matters for the users.
Jeff, thanks so much for that insightful background and vision. Pardon the pun, but you're a real industry luminary in Edge AI and vision. I really thank you for joining us today, and I look forward to us working with you throughout 2025.
Thanks for having me, Steve. Great to be here.
You're welcome. Take care.